Hey everybody, I'll be doing some Leetcode problems today, but not only doing Leetcode problems, I'm gonna be going through like the methodical, step-by-step way you should be doing like during an interview. So let's jump right in. Okay, here's the top 150 interview questions in Leetcode, and I guess let's just might as well start at the top. Okay, merge sorted array. So you are given two integer arrays, nums1 and nums2, sorted in non-decreasing order, and two integers m and n. M and n. Wow. Representing the number of elements in nums1 and nums2 respectively. Merge num1s and nums2 into a single array, sorted in non-decreasing order. The final sorted array should not be returned by the function, okay? But instead stored inside nums1. So we shouldn't avoid anything here, just I guess copy, or not copy, but just modify nums1 in place, I'm assuming. Nums1 okay, has a length of m plus n to do this, even though it's a vector. It still has space already allocated for the whole thing, and essentially setting the last n elements to 0 here. Okay, and then essentially like, okay, usually you're gonna be given this question right away, and there's not gonna be any examples given. So your first your first step your first step here should just be, before doing any examples, is like just ask clarifying questions. Okay, and understand input constraints. Okay, so what is this here? Okay, so our input constraints. Um, okay, so we have integers here as the input, a vector of integers obviously, or vints, we could just say. So that's our input. We also have size, which is an input as well. What are the ranges for these values here? So we can go down here. Nums1 is always equal to m plus n, and nums2, let me just copy it, is always equal to this. So you definitely want to clear those up, because in the interview you're not going to be given these constraints, so you want to make sure you understand these. And I guess constraints on m and n here, and then more constraints on m plus n. Then I guess we also have what the values could be. So ints in this case are, I guess, 10 to the negative 10 to the 9 and up to 10 to the 9. And it looks like it's inclusive. So okay, so from here now we want to like, either once we understand like, okay, these, like, we understand like what the problem is telling us to do, you clarified any questions you have, you need to clarify them like at this moment, and obviously while you're coding, but it's best you do it now. So we don't have to run through the examples. You normally wouldn't in the interview right away, but maybe we can just talk about the solution at first. So first, there isn't a requirement to do this in place, but we need to make sure that nums1 is being used. We're gonna just write it better. Not required. So in place is not required here, but we have to make sure nums1 is modified. So essentially it's pretty much in place, but we have space for this. Okay, so, and then obviously we need to sort this in non-decreasing order, which just means increasing order. Okay, so we have that. So let's just talk about possible solutions. And like, you should definitely always do a little bit of pseudocode, or at least like write down your solution, and have the interviewee or interviewer like sign off on it before you start coding. So a possible solution here, right? So let's think. So you want to loop through nums1 and nums2, and they're both sorted. So we want to make sure that when we modify nums1, that we put the element that's smaller first, because we want it to be increasing order. So compare nums1 and 2 and add the smaller one first. Okay, so, and then how do we make sure, because we don't want to increase the length of m plus n here, so we don't want to push back or anything. So we have to like basically overwrite the index, but we also need to save whatever we're overwriting if it shouldn't be, if it needs to be saved, for example. If we can't, we shouldn't lose that. Ah, sorry, let me just write down second step, discuss possible solution. Discuss possible solution here. Okay, and sorry, just let me make this a bit better. Okay, that's a bit better. We probably want to loop through in reverse order just because we do not want to push back here. Loop through reverse order, compare values between nums 1 and 2, and add the smaller one first. So now, let's see. Now that we actually got something written down that's, viable here, let's try to code something up. So third step is start coding. So let's see. So we have to keep an index here. And in the index, let's say we do int I. So for nums 1 here, it's going to have to be equal to the m minus 1, obviously, since the index start at 0. And then int j would be equal to n minus 1. And this is response, since n is for nums 2 here. I know it's using a vector. We could just use the size, but I'm assuming this wasn't meant to be a vector. I guess there's supposed to be arrays here. But anyways, let's continue. So we could say then, like, while I is greater than or equal to 0 and j is greater than or equal to 0, we need to do something. Do the comparison and swapping, I guess. So basically, first if statement, if nums 1 I is greater than or equal to nums 2 j, then we want to do something here. We want to say nums 1. This is interesting. So what does the index need to be here? Looks like we have to keep track of a third index because we have to actually have the place where we're actually going to be setting this. And for this, we could just call it K here, just to be consistent with everybody else in computer science that uses just letters and stuff and not descriptive wording. This one here has to be, I believe, the size of both of them together, since nums 1 is going to be m plus n sized. So we want to start off at the end of that. So n plus n here minus 1, obviously, to take care of the 0 index for that. So k would be here, and then this becomes nums 1 I here. So this takes the place, and then that takes care of this situation where nums 1 is bigger. And in the other case, we had to set it to nums 1, k has to be equal to nums 2 if it's bigger. And this should be, I believe, yeah, j. And then we can just continue on here. So I minus minus or j minus minus to take care of the correct one, of the correct index, and keep track of that. So we get to this portion here, and after this, we have to take care of the fact that I or j might not go all the way to 0, and it seems like, yeah, I or j may not go, yeah, definitely cannot go, might not go to 0, so we need to take care of the remaining index, or remaining array values that have not been checked. So here we can say, like, while I is still greater than 0, then nums 1 k is going to be equal to nums 1 I here, because if I is greater, that means that the nums 1 hasn't been fully satisfied or fully looked at. So then we can just do I minus minus, and then same thing, but for j and for nums 2 values instead. Or actually not, wait, I think we also have to do a k minus minus here. Let's see. I might be missing that somewhere. It's something good to catch on your own. So for example, like I just realized that I haven't even been subtracting or removing the k value, or moving the k index value from where it starts off at here, and I just been setting it. So right now, if I were to run this code, or if I were to tell the interviewer like that this code looks good to me, essentially, obviously, it's going to be wrong. It's only going to be updating this k value. So it's definitely something good when you catch it on your own. But the interviewer will sometimes give you hints if obviously because they're most likely going to see it, and don't take it as like negative points because it's technically not. If you're able to, if the interviewer is able to identify it for you, and you're able to then go, or not necessarily they don't identify it for you, they give you a hint on something that's, they kind of like move your eye towards it. So they might tell you like, um, you should look at, make sure that your indices are correct, and then you look at you'll look at them and you'll realize like if you're able to identify that the k value isn't being decremented here, and then understand how to handle that and figure that out and find the solution to handle that, that's still like a very very good positive signal for them, and they definitely do still like take that into account. So here, for example, I should be incrementing the k value no matter what, I believe. So for example, here we identified the k needs to be decremented in both instances here. So not only this, but here too, and just in case here as well. Okay, and just like before you tell the interviewer you're done, at least like double check everything. You want to set your eyes at the m value for corresponding to nums1, n is the size for nums2, so that's the j. K should always start at m plus n minus 1, and then you just want to go through this. So step 4 here to verify this stuff is test cases. So this is gonna be as simple as just saying like, let's just make it simple here. Test cases, test a few things. So like, luckily we have these down here. So like, if we say nums1 is equal to this, let's run through it in our algorithm right quick. Let's see what happens. Okay, so we have nums1 is 1, 2, 3, and then nums2 is 2, 5, 6. So we have 3 and 3 for each. So I should be 2, j should be 2, and k should be m plus n 6, or it should be 5 here, minus 1, 5. So this value here, I, is going to be 5. So when I is equal to 5, j is also equal to 5, and k is equal to 5 as well. And then we will need to, hope we can bring this down. Okay. So the first while loop here, we have both of them are more than 0, so it's okay. Move in. Nums1 here, nums1I here is going to be 5 is going to be equal to 0. Nums2 5 is equal to, oh, I made a mistake. And they're equal to 3. So actually this should be 2, this should be 2, and this should be 5. Okay. So 2 and 2, which equals 3, and this equals 6. And then we know that 6 is bigger than 3, so nums1k, which is 5, is going to be equal to 6 here. And let's do, so now j gets decremented, so now we have I equals 2, j equals 1, and k also is decremented, so it equals 4. Here we know that nums1 of 2 is equal to 3, and we know nums2 of 1 is equal to 5, and nums2 1 is 5 is bigger than 3, so we'll do nums1 4 is equal to 5. So this is the expected output, I believe. Let's look at the test results here. Let's run this test case. Hopefully it runs. Oh, got a wrong answer on the third one, but okay, it worked for the first one. So it worked in this case, and that should be the expected output that we expect. So, once after you verify, you'll tell the interviewer, like, do you think this is good? They'll most likely then hit you with what's the runtime and space time of this. So if you can figure that out now. So let's see, it's runtime and space time. Let's see the runtime first. So we have this here, which at worst case will be going m or n length. like whatever's shorter in this case. So I guess in this thing has like an upper bound of whatever's bigger here. I guess the upper bound could even just be n plus n here, and you have to loop through at least the rest of the other one. So in this array, you're going to loop through the shorter one of n plus n, of n or n. So in this array, you're going to be looping through the shorter one of n or n. And then from here, you're going to take care of the rest. So essentially, what you're going to be doing here is basically just going through having an O of m plus n. So the runtime here is m plus n, where m is the size of array of nums1 and n is the size of nums2. Okay, so now let's take care of the space-time. Since we're not using any time, we're using no temporary vectors. We're doing this all in place. There should be a constant time or a constant space-time. And essentially from there, your interviewer will move on to the next question, or if the interview's over, then they'll let you ask any questions you want at that point. Thank you guys. This is my first time doing a Leetcode problem, and I like to do more and hopefully teach you guys or help you guys learn like how you should be doing them in interviews, especially in interviews, because that's why we're doing Leetcode problems. So thank you guys all, and hope you guys have a good rest of your day.